like you have some knowledge of block storage architecture, so that I can differentiate between the aggregate storage and block storage cubes. You know, Hyperion Essbase is a multi-dimensional database system, or you can say it's an OLAP system. Uh, data is stored multi-dimensionally over here, so that you can slice and dice and drill down, drill up the data uh, in a good to see format. So, and block storage is one of the architecture, and the another architecture is the aggregate storage. So today I'm going to talk about the aggregate storage architecture and how it is different from the block storage cubes. Okay. So when do we need the ASO cubes? I'm going to say ASO throughout my training rather than saying the aggregate storage. Yeah. When do we need the aggregate storage cubes? Like if you have little knowledge of the block storage cube, you would see that you would notice that if you keep on increase the database size, if you increase the metadata that is outlined, the performance will get slower. Like if you keep on increase the users the performance will also get slower. So ASO is basically used to increase the performance in reports as well as in Excel add-in, and for the rapid aggregation. If you have lot of metadata and you want that to be aggregated very quickly, and you don't want to perform the calculation explicitly, then you would use the ASO cubes. And how is this different? I'm gonna keep on telling how it's completely different. The calculation is different, the outlines are different, the architecture, the kernel is different, the reports are different. You can retrieve the same kind of reports though. That probably would not be the right statement to say. You can retrieve the same kind of reports, but it's calculated very differently. The reports are calculated on the fly while retrieving, rather than explicitly in block storage via cal scripts. Yeah, no cal script, Jack. There are no cal script. In the latest version, actually, just few months ago, Oracle has come up with the latest version of ASO. They say that there is a possibility of calculation scripts in ASO, but that is very limited, and that's very limited to level 0 members only. But there are no calculation scripts. So that option is still getting explored throughout the industry. Okay, the first one is the database is sparse and has many dimensions, and the dimensions have many level of members. Like if, as I said, if the database is your database is getting bigger, your organization is getting bigger, you have a lot of metadata. You for the reporting purpose, for the performance purpose, you need the ASO cubes. The database is used primarily for read-only purposes and with few or no data updates. When you use a database or a cube, for the reporting purpose, you don't want to update it frequently. Otherwise, you would have the outages. So most of the time in aggregate storage cubes, you update the data, at the scheduled time, like once a month or once a quarter. So once the month gets over, you get the new data from the functional people. Then you load it. So, but that doesn't happen in block storage cubes. in block storage cubes, yeah, you keep on getting the data and you keep on loading and you keep on doing the calculations and aggregations, so many things you can keep on doing it. And the block storage cubes are also used for planning purpose. So data is keep on getting updated in block storage, but that doesn't happen in aggregate storage. It happens very limited, because when you update the data in ASO, you have to update most of the time the complete database. So there will be an outage, and you don't want the reporting queue or reporting database to get the outage. Okay. The outline contains formulas most of the time in the dimension tagged as accounts. So, well, we can have the formulas in all the dimensions, but most of the time, I'm talking I'm from the consulting background, so I'm not telling you the training. Most of the time, the formulas are in the account dimension, where you have to do the account related calculations like net profit, balance sheet calculation. There are a lot of calculated accounts in the company, those kind of calculations. So most of the things, most of those calculations happen in the account dimension, and all other calculations, we get the data at the level 0. So we get the calculated data. We cannot perform the calculation because that's not the purpose of this cube. The purpose of the cube is reporting, to get the reports out of it. And formulas are embedded in dynamic calc tag members. You cannot add the formulas in any other members. When you define the formula in the member, that member has to be tagged as dynamic. So we have the stored option also. In the stored option, you cannot embed the formula. Calculation of the database is frequent, is based mainly on summation of the data, and that does not rely on calculation scripts. So, as I said, we have very limited formulas in ASO, and more that whatever we have, they mostly are in the account dimension. So it is basically the architecture. These kind of cubes are basically used for the reporting purpose and for the rapid aggregation on the fly while retrieving. So all the aggregations, all the summation, negation, those kind of consolidation, all those kind of consolidations are happen in the ASO cubes. Okay. So I'm continuing with the summary. The main difference between ASO and BSO, as show you below, ASO can support large scale of members such as customer individual analysis. For example, if your customer dimension has 1 million members, the aggregate storage member will be faster than BSO. That is the purpose of the ASO. Like you can keep on adding the. Just got a question from Jack. Can an end user differentiate between block storage versus ASO using add-in or smart view? No. The end user won't be able to differentiate unless the end user is a business user and he has to update the data via lock-ins, via lock-in sense or via planning. In planning, you cannot have the ASO at all. I hope I have answered your question, Jack. Okay. ASO supports limited write-back, but BSO fully supports. Yes, and that only happens in the latest version, actually. in the previous old versions, we could not even do any kind of write back in ASO. So you can load the data in ASO via at the level 0 only. You can do that via rules file as well as via XLRIN or SmartView, but that happens only at level 0. ASO can support large-scale aggregation, but for another purpose such as what if or allocation should use BSO. Like if you want to copy the data, if you want to allocate the data, if you want to perform big calculations, ASO is not the cube you like to implement. That you will need the block storage in that case. The purpose of ASO is rapid aggregation, the large-scale aggregation. For example, Citibank has the branches across the world, maybe thousands of branches, and every branch has different departments. So you will need a million members in your organization dimension. All those aggregation would be easily implemented in the ASO cube rather than the BSO cubes. Okay. For architecture of calculation, ASO use MDX script and block storage use calc scripts. Like if you know block storage cubes, we use the calculations via the calc scripts in block storage. But in ASO we have the MDX script, and to define the views and aggregations, you use the MDX script, and the formulas are also in the MDX formats, not the calc script format. The format is completely different. And MDX is not native to Hyperion, whereas calc script is native to Hyperion. Okay, let's point. For cube that have many dimension and more member, ASO can save storage space more than block storage cube. If you keep on adding the members in the block storage, and obviously the data would also increase, the size of the index files and the page files of the block storage will keep on increase, but that doesn't happen in ASO. If you add the members and if you have the data for that member too, all those data and the metadata get accumulated only in one file. So the compression is completely different. The kernel is completely different of the ASO, and it takes compared to block storage very less space. So that really helps in large scale reporting. Okay. When you add or delete or change the dimension in the outline, the entire data will remove. In block storage cube, if you delete the dimension and you have the data loaded in it, it will ask you whether you want to keep the data, and it will restructure the data accordingly. But that doesn't happen in ASO. In ASO, if you delete the dimension, the data will be removed. You have to reload it, because it cannot restructure so many dimensions as per the data. It has to synchronize the data with the outline. Block storage cubes can do that easily because it does not have the big outlines. But that's not the architecture of ASO. If you delete the dimension, the data will be removed. You have to reload it. In a standard dimension, plus and the consolidation of property only. In the measure, negative, the symbols are there. Like in the stored dimension, you have the option of stored dimension over here. We have the dynamic. So you have the regular consolidation flags. But in the dynamic members, you can have the formulas, and you can have percentages. You can do complex calculation in the dynamic members. And the dimension can have two type of there are two types of dimension. They are dynamic dimensions, and they are multiple hierarchy enabled dimensions, and they are stored dimensions. So I'll explain you those things later. In ASO, we have one database per application, whereas in block storage queue we can have multiple databases per application. Although it is not recommended even in block storage. So there is a very strong reason for that. Like in block storage, if you have multiple databases per application, the logs will all messed up. But in ASO, we just have one database per application. So it's understanding the logs is pretty easier. And in the block storage, if you have 3 databases per application, when you troubleshoot for anything in block storage, the logs will be messed up. So it's not recommended at all. You should have one database per application. As I said before, there are no calculation scripts and formulas. And there are no 2-pass calculations and no variance calculations. Instead of 2-pass, we have another methodology. I'm not sure whether the webcams are allowed. Yeah, I was saying, like, for the 2-pass calculation, we have different methodology in ASO. That is the solve order property. That's a solve order tag. I'll explain you later on that. Okay. I'll show you rather. See, this is one of the examples of ASO cube. If you install Essbase on your computers, this is probably the default application get installed. Like, this is the account dimension. Here we have the formulas, and this is the solve order thing I was talking about. See the number 10, and 10 is the solve order thing. The higher the number, the more priority it will have. And in block storage, we used to have the 2-pass calculation. So data gets calculated in the second pass when you retrieve it. Okay, inherent differences between ASO and VSO. ASO applications differ from block storage applications in both concept and design. Storage kernel architecture that supports rapid aggregation, optimized to support high dimensionality and sparse data. It doesn't have dense sparse concept. Like, if you are familiar with block storage, we have the dense sparse concept in block storage. That's not there in ASO. Most of the data would be sparse in ASO because it's not made for the calculations. It's the purpose of it is a rapid aggregation, rapid consolidation via reports or via Excel or any other reporting tool. So there's no concept of dense or sparse in ASO. Most of the data will be sparse only. Physical storage definition through the application properties window. If you want to see the physical storage, what are the files in the kernel, you should go to the properties of the database, and you can go to the. I can show you over here. Like this is the database. This is the application. Go to the properties over here. This is the general properties, like how many dimensions we have. It's going to show you the dimensions and all the dimensions members. It's going to show you in all the in the properties. Also, the stats, like how much bits are used and all. And when was it got modified last time, who loaded the data. We're going to tell you this, who modified the data as well as the metadata in the modifications tab, and also the compression, what kind of compression we use. At this point of time, we have not used any compression here, so it's not showing anything. And if you see the physical storage of block storage is completely different. We have the blocks over there, the concept of blocks in there in block storage, it's not the aggregation. And sparse dimensions, dense dimensions, those kind of stuff would be there in the block storage. How would you create that? How would you create a aggregate storage application? The aggregate storage application can be created via two ways. One, you can migrate a block storage queue to the aggregate storage queue, and then you can change the formulas. As I said before, the formulas in block storage queue would use the cast script commands, but in the formulas in aggregate storage would use the MDX, which is not native to Hyperion. I can show you, how to migrate the data, migrate a block storage queue to the aggregate storage. If you click on File, go to the wizard, there is the aggregate storage outline conversion, so where you can convert a block storage queue to an aggregate storage queue. You have to choose the cube over here, a block storage cube. The block storage cube would have this kind of that thing, and then aggregate storage would have a star on it.